Okay, so let's take a look. We're going to move on to chapter 9, section 5. Okay, so how do you find the inverse of a function? That's our essential question. In case you want to know, this is chapter 9, section 5. I'm going to write that right here. Okay, so when do we do a horizontal line test? We already know about the vertical line test, right? And the vertical line test, we do it when we want to find out if the existing graph that you see is a function or not. The horizontal line test is used to see if the inverse of this graph is a function. So what you're going to do is you're just going to go ahead and draw a horizontal line, and every single time if the graph hits the horizontal line at only one point, then yes, the inverse, okay, the inverse of this graph is a function. So then I want you to work on the second one yourself, okay? So go ahead and draw some horizontal lines. What's your answer? Well, I can't wait for you, so let me just do it. So I'm just drawing some horizontal lines, and I notice right away, look at this line. The graph is touching this horizontal line at 2 points. Same thing over here, right? So if you have more than 2 spots that's touching the horizontal line, then you know that the inverse is not a function. The inverse of this graph is not a function, okay? I don't have space to write a function. So let's move on to our question. It says over here, oh, I just realized you can't really see part of this. It says use the horizontal line test to determine whether the inverse of each relation is a function. Go ahead and do it yourself. You know the answer for A. A is yes, and the answer for B is obviously no. The graph has been cut off, I realize that, but still you can see that, right? Let's move on to question number 2. Find the inverse of f of x is equal to blah, blah, blah. Okay, so now you have to actually find the inverse of this graph, okay? And what you have to do, in case you don't remember, to find the inverse of anything, you have to just switch the x and the y and then solve for y. So let's just do that. F of x is just a fancy way of saying y. And then I'm going to copy the rest, 1 over 2x plus 2 squared. And we have to find the inverse of this. And all we have to do is switch the x and the y. So what I'm going to do is I'm going to erase the y and the x, and then I'm just going to switch it around. I'm going to put x here, and then I'm going to put y here. Then I have to solve for y, which means I gotta leave the y by itself on one side, not the x, okay? So everything is inside the parentheses, and we have a squared right here. That means we have to undo the square. In order to undo the square, we have to actually find the square root, okay? So let me rewrite this. So to undo the square, we have to find the square root of both sides, okay? So then we're going to end up with square root of x equals 1 over 2y plus 2. Now, my goal is to leave the y by itself. So I'm going to go ahead and subtract 2 from both sides of the equal sign. So I have square root of x minus 2, and that equals 1 over 2y. I still want the y to be by itself, right? So I'm going to go ahead and divide both sides by 1 over 2, or in this case, multiply both sides by 2. Okay? So what's my answer? The 1 over 2 and the 2 cancel out, so y is equal to, and then the other side is 2 times square root of x minus 2. Whether you distribute the 2 or not, it doesn't really matter to me. Okay? And so there you go, that's the inverse, okay? But then it also tells me determine whether it is a function or not. Well, in order for you to determine if this is a function or not, you are supposed to graph this on Desmos. You're supposed to graph this one on Desmos. And when you graph that, you'll find out that it looks like, on Desmos, it looks something like this. Okay, so if you do the horizontal line test, you know that it touches more than one, so it is not a function. Okay, so then you have to say The inverse is not a function. Then finally it says state is domain and range. For the domain and range, now what you gotta do is you gotta look at you have to graph this one, okay? And when you graph that on Desmos, you will see that it looks something like this, okay? And so what do you think the domain and the range is? Well, you'll have to look at this and decide looking at Desmos. But you know what? Let's not worry about the domain and range, okay? So as long as you can go as far as this, just because explaining to you how to find the domain and range will be much more effective if I do it in person. So I want you to stop right here. So on the test, I won't ask you about the domain and range. So you have to know how to find the inverse and then know that the inverse is not a function. And that's it. Here's your practice question, and I gave you the answers in red. I know this part is covered up. The domain is all real numbers and the range is all real numbers, okay? So you can see. So we're almost done with the lesson. In order for you to identify the inverse of inverse functions, you have to use the composite function that you learned yesterday. That's why we did it yesterday. So if the composite function of f of g of x is equal to g of f of x and they both end up being x, then you know that the two equations are inverse functions. So what does that mean? Let's solve a problem. Okay, so we have to determine by composition whether each pair of functions are inverses. So we have f of x and we have g of x. So it's kind of easy. We have to do the f of g of x and then the g of f of x and make sure that they are both equal to x, okay? So let's do that. We have to first do f of g of x, okay? And then we gotta do g of f of x. And we gotta make sure that our answer in the end ends up being what? X. Okay, so f of g of x. So we have to think about yesterday's lesson. We have to start off with g of x, which is 1 over 2x minus 4. And then we got to put that into f of x. So f of x is 2x plus 4. What that means is, instead of x over here, I'm going to put in 1 over 2x minus 4. So I'm going to put that in parentheses, and then I'm going to put the 2 at the front. And then I'm going to put the plus 4 in the back. Okay? So let's do this. 2 times 1/2 is 1, so that's going to be x. 2 times negative 4 is negative 8, and then plus 4. Oh no, what is that? So that's going to be x minus 4. We already know that these are not going to be inverses, right? Because instead of getting x, we got x minus 4. So let's try g of f of x, okay? I'm looking at the book to make sure. Okay. So then we don't even have to do g of f of x because we already found out that the answer for this one is not x. But let's just do it, okay, just to practice how to work on composite functions. So first we have to start off with f of x. F of x is 2x plus 4. So let's put 2x plus 4 first. And then we're going to have to put that equation into g of x. So instead of this x over here, we're putting in 2x plus 4. So I'm going to put this in parentheses because that's going to go in instead of x. I'm going to put 1 over 2 at the front. Then I'm going to put minus 4. I hope you understand what I'm doing. So now half of 2 is 1, so that's x. Half of 4 is 2, so that's plus 2. And then we have minus 4. So that ends up being x minus 2. Obviously, this is also not equal to x. So what is your answer for this one? I'm going to have to take you to a new page. The answer for that one is f of x and g of x are not inverses of each other. And that's it. So I'm thinking that this lesson is super easy, but I don't know how you feel about it. Here's your practice question. Determine by composition whether each pair of functions are inverses. So you try it, and I already gave you the answer so you can check your work, okay? So for me, I think this is the easiest lesson ever, but maybe for you, it's hard. So come ask me questions if you need to, all right? Happy learning.